Equivalent fractions. Page 134. When you think of equivalent fractions, what is it you think of? What are equivalent fractions? Yeah, fractions that are equal. In other words, fractions that represent the same value. The classic example for fractions is what? Using the pizza, right? Slice up the pizza into different combinations as far as pieces, and you can talk about how many options you have. Okay, so if it's you're gonna have half the pizza. Very rarely, I'm not saying it's never been done, but very rarely when you cook a pizza at your own house and you throw it in the oven, you throw your jacks in the oven, very rarely that when you pull it out, you cut it once right down the middle and then you start eating. No. Very rarely. Not saying it hasn't happened. Okay? But you cut it once and you just grab the one big half of it and you start going to town, right? Not usually, right? Usually, well, maybe, but not usually. Usually, you may want to cut it into eighths. Pieces are a little more manageable. If I'm cutting it up for the kids, maybe I'll go 16ths, a bit smaller. So you cut them into smaller pieces, they cool off faster. Really? Yeah. Yeah, because all that heat that's trapped underneath the cheese, the more you cut it, the more that heat escapes out the sides. Right? Makes sense, doesn't it? Okay. So if I were to say, all right, I still want to eat half that pizza, but instead of eating one big piece, I'd rather what, Willie? How many of the 8 would I have to eat half? 4. Those are equivalent fractions. If I decided to go 16ths, then how many? 8. So just because they look like they're different fractions, they're actually the same, because your tummy will still feel just as full if you ate 8/16 of a pizza as it would if you ate half, or if you ate 4/8 of it. Really? What about it? That depends on how they cut it. I don't get Papa John's.
Little Caesars. Wait, you don't like Papa John's?
Little Caesars?
Yeah.
Hot and Ready's?
Yeah. I love it. $5 for a large pizza. What about Pizza Hut? Pizza Hut.
It's all fast food pizza. You want good pizza, you get real pizza. Domino's, Papa John's, Pizza Hut, Little Caesars. That's all fast food pizza. Fast food pizza. Get a Lolly's. Get a Lolly's. 88th and North.
What about Balestrari's?
Balestrari's. Get a Balestrari's. Equivalent fractions. Now, there are 2 ways in which we can get equivalent fractions. One way is through multiplication. This is the easy way. This is the easy way to produce equivalent fractions. So if I gave you the fraction 4/10, and I wanted you to give me 3 equivalent fractions for 4/10, using multiplication, you can use whatever you want because you can multiply any number times any number. So if I wanted to play it safe and say, okay, I'm just going to multiply by 2. As long as I do what? Multiply both the numerator and the denominator by 2, then I should be set. So 4 times 2 is 8, 10 times 2 is 20, 8/20 would be an equivalent fraction to 4/10. What if I wanted to go by 3? 12 over 30. If I wanted to go by 10, 10 is actually really easy. Just add a 0. to the top, add a 0 to the bottom. Right there, we have 3 equivalent fractions using multiplication. You pick. You are in control. You decide what you use. If you decide to use 47, then you're making the problem harder than you need to make it. That's up to you. You can do that, but it's not entirely necessary. The other way is by division. Division is a little more challenging of the two. Not that it's impossible, but a little bit more challenging. If I keep that same fraction, 4/10, can I pick whatever number I want to divide the numerator and denominator by?
Nope.
Why not?
Because it won't go into.
They're not all divisible by the same thing. I need to find out what is it that I can divide a 4 and a 10 by so that I can break them both down. So 2, 4 divided by 2 is 2, 10 divided by 2 is 5. Okay. 24 over 32. 24 over 32. Yes, we're using division. Any suggestions? Yeah. 8. Goes for the throat. Right for 8. So 24 divided by 8 is 3. 32 divided by 8 is 4. What is 3, or what is 8, excuse me, in relation to 24 and 32? What is the 8 in relation to the 24 and the 32? Trinity. 8 times 3 does 24, but what about the 8, how it relates to the 24 and the 32? 8 is their what? Really? Close. Common something. No. Raven. No. Keith. Raise common factor. The 8 is their GCF. Remember, if I were to go back and just give you a quick refresher on the GCF, GCF is where we list them. There would be the prime factorization of 24. 32 is 4 times 8. That would be 2 to the 5th power. Remember with GCF, we circle what they have in common, write it down. Circle, write it down, circle, write it down. What is 2 times 2 times 2 times 2? 8. If I divide my numerator and the denominator by their GCF, I will always get a fraction that's in what? Can I break down the 3/4 any more than it already is? So therefore, it's in, really? Simplest form. I cannot break down 3/4 any more than it already is. 3 and 4 have nothing else in common, and I can divide them both by. Therefore, they're in simplest form. What about 4? What about 4? I can use 4. But is 6/8 in simplest form? Why? Because I can still divide 6 and 8 by what? 2. Okay? So you'll be asked to put fractions into their simplest form. Now, sometimes you have the option of just kind of having it and trying to chop it down as best you can. And sometimes they don't give you that luxury. Sometimes they'll ask you for the GCF. Because I am so fair, you know it, I will give you the opportunity to break them down and put them into simplest form without forcing you to find their GCF. However, if you can't do it accurately, the next step will be you'll need to find the GCF and divide by that. So that'll be the second part of it. So if you're going to do the redo, I may say, okay, you need to find the GCF and then put it in the simplest form. So let's try some and see how you do. You've done this plenty of times before. 14 49th and 20 100th. What is the only thing they have in common? 7. So 14 divided by 7 is 2 and 7. So double check though. Double check and make sure that 2 and 7, do they have anything in common? No. 7's prime, 2 is prime. Therefore, if both of your numbers are prime, there's a good chance that there's nothing else. 20 and 100. This is one where you can keep chopping, right, Trinity? What did you start off with? She started off and she said they're both divisible by 5. Got 4 20th. Then, with little help, she realized that they could still be broken down, and she went 2 over 10, and then 1/5. So 1/5 is where we want to be. Some of you might realize right away that they're in common. Divide them both by 20. If it takes a little while and you got to keep chopping, that's fine. Now, Trinity and anybody else, one of the first things you want to look for is if they're both even. They're 4 and 20 even still, then they're at least divisible by 2. That didn't help you much because it gave you 2 and 10, which are still even, but you could divide those by 2 as well. So where it gets tricky is they're not all going to be divisible by 2 if you don't catch them in simplest form right away. Maybe they're divisible by 3, or maybe they're divisible by 5, or something else. You have to be on your toes. Yeah. 12 and 18, what is their GCF? 6. So if 6 is their GCF, I should end up with 2/3. 9 21sts. 3 looks like their GCF to me, so Trinity? 3/7. Good. 2/3, 3/7. Take out your 3-4 worksheet. 3-4. Well, we kind of skipped in between. We went from 3-3 to 3-7, or 3-6. It's a pink one.
Thank you.
You got it.